Hello guys, so today we are going to learn how to make this PIR sensor module. So whenever I move hand or I keep it here and move, the light will be flickering. So this is actually used in a home automation system, and you can say that you can use it for the security purpose. So now this is very simple project to make, and let us learn how to make it. So in this what we are going to do is we will record the time of how much the motion was when the motion was started and when the motion ended. So that will be recording in the monitor. So let us learn how to make this. And now all we need is only 6 things. So let's see what are those and we will make the connections. So all we need is only 4 things. And what are those? Is one is we'll take a jumper wire, that is male to female, and we will take an LED, that is also known as 5 mm LED light, and we will be needing a PIR sensor module like this, and we need an Arduino, which is most important thing in this project. So Arduino, I'm using Arduino Uno, which is R3 version, and you can use any Arduino Uno for this project. And we need a power cable. So this is actually USB, which is data transfer cable, and the power cable as well. And now just for balancing purpose for sensor, I'll be using the breadboard. So all we need is only these 6 things. So one is USB power cable and the male to female wires and breadboard, Arduino and LED. So let us learn how to make this. So let's start with connections. As you have seen the circuit diagram, now let us make it. So first we'll take the Arduino and the PIR sensor and LED. And the most important thing, we'll take the male to female jumper wires. So first thing we'll do is we'll remove this. So what exactly is PIR sensor? PIR sensor is a passive infrared sensor which will be reading only passive infrared rays. And this is the module where all the sensing is done. And when you turn it, it looks something like this. And here are the pins from which we'll be connecting this to the Arduino. And what are these pins? We have GND here and output pin and VCC. So GND is negative, which is ground pin, and VCC is a power pin from which we'll be taking the power to the will be giving the power to the sensor. And we have output pin from which the output will be sent to the Arduino. So here the input is the sensor and the output is the Arduino. So let us see how to make the connections. So first I'll connect all the 3 pins of the PIR sensor. So after connecting it, now I have connected VCC and output and ground. So first thing I'll do is I'll connect the ground to the ground pin of Arduino. So in Arduino there is a confusion might be taken up. So we have digital pins here, which is also named as PM. So these digital pin are used for taking the readings and the information which is given from the sensors or anything which you have connected it. And on the other side we have analog and digital power pins. So what exactly is this? The analog and power pins are actually for giving the power and the message for the Arduino. So here I'll be connecting the GND pin of our sensor to the ground pin of our Arduino. So see, here is GND, which is a black color. So GND is connected with ground. So the ground is connected with ground. Next, we will give the power to the Arduino. So 5 volts. Why 5? If we are using any like you are using directly, you're giving the power from your computer, then we'll be using the 5 volts. If you're using any batteries like 3.5 volts, then you will be inserting this pin to the 3.5 volts of positive side of the battery, and if you're using any higher volt battery, it will go to 5 volts, and GND remains same for the negative. And the output pin, as I said, that this side of the Arduino, that is the digital PWM, will be using for input values. So here I will be connecting it to the third pin, because this is where I'm passing the information. So next we'll take the LED, and in LED we have two sides. One is longer and one is shorter side, which is also known as cathode and anode. So the smaller one is negative and the bigger one is positive. So positive side of the pin LED, I'll be connecting it to the 13th, and the negative I'll be connecting it to ground. So now our connection is done. And to balance this, I'll be using the breadboard, but before that I'll close this lid and I will keep it here. So now our circuit is ready. The only thing is now we need to give the power. For that I'll be using the same cable to give the power, and let us see how it works. And I will give the power directly from the computer. So after connecting it to your computer, I'll be connecting this back to Arduino. So now our connections are ready. Let us see the code. Seeing the code. So as we can see on the screen, there is a big code which is of 74 lines. We have connected it to, we have to insert it into the Arduino. So here in the code, first we'll be giving the calibration time, that is input, we have named as int. Next, we have long assigned input. So that means when we are telling the Arduino to turn off at the certain time, then we want it to pause, right? That means the amount of milliseconds the sensor has to be in a low before we assume all the motion has stopped. So for that purpose, we'll be using an unsigned long with pause, that is 5000 milliseconds. Then we will tell the boolean log low, that is true. That means whenever the boolean value is low, it is true. That means it is correct value. Then the input of the power, that means the digital pins which we are connecting. Whenever we are connecting something in Arduino to the digital pin, then that we have to give the input values for that, so that the Arduino will understand from where to take the value and what value to be taken. So here we have input at power pin number 3, which is output, and LED pin, that is 13. Here PIR pin means the PIR sensor name and the pin, and the LED pin is at 13, so that the Arduino will know there is a PIR sensor at 13, and at 3 we have PIR sensor is at 3 and LED is at 13. So in this, next we will be going to setup. So in setup, as we are writing this in a C language, so we are giving void setup. We'll start the program with this. Then we'll begin with 960. So what is 960? If you go for serial monitor, here we can see bounds. So that is known as bounds. So 9600 bounds. I'm sorry, it is 9600. Then we'll be giving the pin modes, that is input and output. That is PIR pin will be input and LED will be output. And the digital will be PIR and will be low, and the output will be high. Next, we giving the sensor some time to calibrate, because see, when we are using these kind of sensors, it will take time to calibrate. That means it will take time to get active. So we are giving that timing, like delay with 1000 milliseconds, and when it is active, delay for 50, that means only 5 milliseconds. And now we don't want it to happen only once, right? We want it to be doing. That means we need loop. So for that, we'll open the program for loop. Next, we'll go for digital pin, as we know that if the digital pin, PIR pin, that is high, that means it is on, then the LED visualizes the sensor output in the pin state, whatever the output is. Then we want to make sure for the transition to low before further output is made, right? So for that, making sure will lock some values, like lock low will be false. When the output is locked, then that means that is false, that is not a true correct value. Then serial print will be motion detected at certain time and motion ended at certain time, which will be writing in this part. Next, we'll be telling it how to calculate the time, that is milliseconds, certain milliseconds minus pause divided by 1000, so that we'll get proper time in seconds. Then delay for 50 milliseconds and give the output. So now after this, let us see how if it is correct, or we have any error in that. For that, we'll go to file and save the sketch. After saving, as I have already saved, I don't need to save it again. After saving, Control S, and it is saved. So now what we'll be doing is, we will check if it is correct, we'll verify, it will compile and verify if as we can see that there is no error in our program, we are ready to go. But before that, we should select the board, which is Arduino Uno and COM is 6. So if you are using any other board, you can go here and search for a board name like Arduino Uno. Sorry, I've made a spelling mistake. Okay, so as I have selected it, and the serial port will be USB, I'm using only one port here, so I don't have any other port. If you're using any other port, then you have to be careful with that. Then we'll click on OK and see. So now, as we are not doing any motion in front of our sensor, it is not detecting. And when we do, it will stop. Oh, sorry. And when we do, as we can see that the LED is turned on. And in our screen, we are seeing that we are detecting the motion. So let us see how we get the exact output in the monitor. So the main thing is, we will see till when and from to the time, like from this time to this time, there was a movement in our in between our sensor and the board. So let us see how it is calculating the time, and that we'll be doing in our computer. After selecting the port and the board, will upload it. So we'll click on upload and we'll wait for it. So it is uploading is done. After uploading, we'll have to activate the sensor. For that, we'll go to serial monitor here on the right top, and we will wait for the sensor to get active. So as we can see that our sensor is active, that means our calibration is done and it is detecting motion. So there was a motion which was detected at the 30th second of the after the activation of the sensor. So like let's say you have activated the sensor at 12 a.m. And I have crossed it at 12:01 a.m. That means your monitor will be showing it has been crossed with at this time. So, where exactly we'll be using it? Like, what are the functions of this? The main functions of this is security. Like, as I have said that you will be sleeping at 12. So, you'll switch this on so that you'll get to know if someone is trespassing. And you can use it in your in home automation also. Like, whenever you're opening the door, the light turns on, or whenever you're passing through some point of your home or something, then the time the light is on. So this is how we make the PIR sensor module. What is PIR? Passive infrared sensor. So this sensor will be helping in doing these kind of projects. So in future we'll be seeing more projects about this, and that's it for today. See you in the next video, future robot builders.